Hello and welcome to 24 Hours of PASS, 20 years of PASS, past learnings and future vision. We're excited you could join us today for Alessandro and Eman's session, Deep Dive into Intel Optane Technology. This 24 Hours of PASS consists of 24 consecutive live webinars delivered by expert speakers from the PASS community. All the sessions will be recorded and posted online at some point after the event. You'll receive an email letting you know when they are available. My name is Mark Broadbent and I'll be your host today. I run the PASS Hybrid Virtual Group, SQL Saturday Cambridge and the East Anglian Data Platform User Group. Before I hand over the reins to Alessandro and Eman, I have a few introductory slides to run through. And I know you guys have already seen these, but I'll try and be quick. If you require technical assistance, please type your request into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You'll be able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note there'll be a short evaluation at the end of the session which will pop up after this webinar ends. Your feedback is really important to us for future events, so please take a moment to complete this. I'd like to take a moment to thank our sponsors, Microsoft and Intel. The staging of 24 Hours of PASS wouldn't be possible without their generous support, and they, the speakers and volunteers, are the reason the event is available free of charge and possible. Intel expands the boundaries of technology to make the most amazing experience possible. Information about Intel and the work of its 100,000 plus employees can be found at newsroom.intel.com and intel.com. And if you didn't already know, I hope you do, Microsoft SQL Server is a business analytics and data platform management engine. It's secure, easy to manage, and gives their customers peace of mind and confidence in the security of their data. SQL Server combines scalable performance with end-to-end business intelligence and a built-in analytics solution. It can be used on-premises, in the cloud, or in hybrid environments. If you'd like to learn more about Microsoft or Intel and want to sign up for information on how they can help you, please visit the sponsors page in 24 Hours of PASS website. So you can keep learning all year long with PASS. Visit pass.org and check out all of their free educational resources available to PASS members. Don't forget that the PASS Summit 2019 will be happening this year on November the 5th in Seattle, Washington. Head over to passsummit.com and register today. This 24 Hours of PASS session is presented by Alessandro Goncalves, hopefully I've said that correctly, and Eman Yarlagadda. I'm sure I've got that one wrong. Hopefully, guys, you can correct me on those two. Alessandro is responsible for performance proof points and solution architect for Optane SSD on the Microsoft platform with over 20 years of experience. Eman is responsible for strategic business development and product marketing of hybrid cloud capabilities in the data center group at Intel. In his 20+ years of experience at Intel, he held multiple roles in the field of networking, enterprise application development, business-to-business engineering, HPC, and hybrid cloud proliferation. And finally, you're not here to listen to me rambling, so it's time to hand over to Alessandro and Eman with deep dive into Intel Optane technology. Okay, guys, just going to hand over. Oh, you should have control now. I'm going to put myself on mute. Welcome.
Thank you, Mark. Hello, everybody. This is Eman. I'll go through a brief set of foils here, introducing the topic and what Intel is doing in the space, and turn it over to Alessandro, who's going to go into a bit of a deep dive into one of the key technologies that we just brought to the market and we think is really going to make a difference in how you run SQL Server and optimize workloads on it. Here is a brief agenda. Intel's new era of data center technology. We'll go through what the fundamentals are around the Optane brand and the technology from Intel, both as a storage as well as memory component. Persistent memory is a term that we're going to be increasingly using, especially with SQL Server 2019. I think this will be a good opportunity for everybody to understand the benefits from that and how does it work, and through some of the deep configuration aspects of the persistent memory through the rest of the talk. Well, I think this is a common problem today that all of us are facing, which is a deluge of data. Data is the currency of the future. I mean, we can come up with more cliches, no shortage of those. This is just 2020 that we're expecting an average internet user to generate about 1.5 gigabytes per day. Autonomous vehicles, 4 terabytes. Connected airplanes, 5 terabytes. Kids and smartphones and app devices on airlines. I'm sure there's a lot going on there. Smart factories, cloud video providers. There's absolutely a lot of data, right? I don't know how many have already bought a refrigerator with IoT. But what do we do with all that data, right? It's just sitting there. And the real shift is about business insights, operational insights, security insights, right? How do you get the intelligence out of that data or the insight out of the data so that your business differentiates with others and can perform better? You can drive operational efficiencies in how you run a factory or your business. Security is on top of mind of everyone. How do you catch these vulnerabilities and avoid the threats ahead of time, right? So for Intel, Microsoft, many of these companies, this is top of the mind. There's a lot of data that's being produced, but how do we drive insights and give the capabilities to the customers so that they can really get to the insights and drive the differentiation for their businesses? Well, we've also noticed that no one is just sitting around, right? We're making investments in this. Customers are making investments in this. You can see surveys that show 82% of enterprises are prioritizing analytics and business intelligence as part of their budgets. We have seen about 90% of the companies are already investing in AI-related technologies. If you really move this trajectory further, it's about AI. Enterprises worldwide are expected to invest 185 billion in big data and analytics and cognitive solutions just in 2019, staggering amounts of money. But we're also learning that not every project turns into a success. There are barriers, right? There are challenges. How do you deal with this growth, technology skills, capabilities gaps? And where I think technologies like SQL Server 2019 and the innovations that Microsoft is bringing and the combined innovation with hardware that Intel is bringing is going to bring that differentiator for you, right? So we know that's a problem of data. We know we're on the right track in making the right investments, and customers, our end users are hungry for those insights, and the enterprises are making those investments. Now it's a matter of how do we put this all together and take advantage of it and bring value to the end user. Right? There's also a ton of legacy out there. But we can't run these modern day workloads on that legacy infrastructure. Everyone likely has already heard about SQL Server 2008 end of support that's coming up in July. Windows Server 2008 is also reaching end of support by end of the year. A lot of that legacy software is also stored or managed on anywhere from 5 to 8-year-old hardware. And the world has changed rapidly, both on the software side, whether it is ability to use the latest hardware features, work with the latest storage, flash-based storage, use high-speed networking, built-in threat detection and protections, as well as the hardware has changed from performance standpoint, from inbuilt security, hardened security aspects. So the differentiator from all these new technologies can't happen. You can't take advantage of that if we don't run it on newer hardware and newer software. So your value prop is stymied, right? You're not able to make that progress. So the first thing we're promoting is modernizing. How do you decide to move on from the legacy software and hardware? And what's the path you need to take to modernize your SQL servers, whether it is migration to the Azure option or to modernize on-prem? Any of those options work, and Microsoft and Intel are here to help. The paradigm with which Intel is moving forward right now really is about the data-centric infrastructure. This is something we have envisioned as really the future for Intel, that everything is going to revolve around data. And Intel's strategy is to drive really a new era of data center technology, right? And very simply put, it's about moving data faster. So there's removing bottlenecks within data center as traffic continues to grow. We have technology investments in that space. You can see on the far left, store more data with the ability to quickly access that data to deliver rapid and real-time insights. Volumes of data means you also need to have innovative storage technologies, and that's the middle. And then process everything with a combination of general purpose and workload accelerated compute products, and a ton of CPU innovation that's happening on the right. And these are the three pillars that we are going to focus on. We're also trying to make it easier for end users and to our partners in adopting this. That is what you're seeing at the bottom, or referred to as Intel Select Solutions. These are pre-validated configurations where Intel and Microsoft and major OEM partners work to validate a platform or a solution and provide that to the end users, so that the end users don't have the burden of figuring out what is the best combination for the type of SQL Server application that they're running. Right? We're already validating it. We're making sure that they achieve a certain level of benchmarks through optimizations. And when you see or ask for an Intel Select solution, then you know that that's a validated system that will deliver the most price performance for you. So today we are going to take a deeper dive into the storage pillar, the store mode pillar, and where we're making investments not only from a storage standpoint, but are also on the memory aspect of this. With that, I'll turn it back to Mark.
Hopefully it should be coming your way, Alessandro.
Okay.
Yeah, it just did. Thank you. Thanks, everybody. And now we're going to do a little bit of deep dive on the Optane technology and persistent memory and the SSD aspect. So as you heard yesterday, we launched our new Xeon Scalable processors, which do support the Optane memory, or the Optane DC persistent memory. But we need to start looking at what is persistent memory. Technically, I guess everybody has an idea, which is, okay, I have a memory that the contents of the memory are not wiped out between restarts, which basically it is correct. But how can we use that? And what types of use case I can leverage today, and which ones I will need to wait until the ecosystem is totally ready? Because one thing we need to understand is the persistent memory aspect is a tripod of resources, one being the hardware, the operating system, and the application. Each one of those layers will have to have some kind of support for persistent memory. So let's talk about a little bit of definitions and terms that you're going to read and listen about out all day long, and from now on, as long as persistent memory starts to pick up steam. First one is DAX, or direct access. Basically is the way a file system has direct access to the memory content. So you can have a byte addressable memory content from either the file system or the application. And luckily, Microsoft and Linux, they call the same idea, which is DAX. So NTFS, ext4, and XFS, whenever you have a persistent memory device, you can mount the file system with a DAX parameter and be a DAX-aware file system. PMDK is a open source library where helps you to use persistent memory on a more efficient and easier way. CLWB, or cache line write back. Basically, it's an instruction that tells the CPU to flush its cache lines. It's L1, 2, 3 cache lines to the MMU, the memory managed unit on the hardware. So the contents of the caches are flushed from to the MMU, and that's what one of the instructions we says CLWB. And actually, it writes the MMU. Inside the MMU, we have a WP which is a write penny queue. Basically, it is a part that is actually power protected and is going to write to the memory media. So the hardware will need to have a power protection on that part in order to avoid any lost writes. And we have the different types of flushes that we are going to be talking about, and whether or not an application does that. A flush basically is to move data from your cache lines to your persistent media, whatever it is, either memory or SSD. It's just how we actually store content. And we have different levels of flush. And we're going to see if an application is not aware of persistent memory, but we have a file system that it is, we can start using some types of different options there. But basically it is. There are a lot of differentiation between standard optimized flushes, and obviously deep flushes, it's another one. But basically, it is where the flush happens, in which layer the flush will happen will be a standard or optimized flush. And optimized will always be called through the set of libraries like PMDK. So a little bit in depth, what DAX it is. It's basically an application has direct access to the memory. So we have a memory mapped region, and the path it is very short. So the more we have an application that's aware of a persistent memory hardware, it will have faster performance, just because when you're doing full load store from the application, you control everything, and the stacks are much lower, so you don't have that much of overhead through the file system stack, volume stack, and so forth. So one point that I mentioned here, where flush request is issued, determine the access type. So if you look at this diagram, we will have from the top two types of access. One is block mode, and the other one is direct access. Block mode is using a standard file API, so regular reads and writes. And we call straight to the file system, which can be a PM-aware file system. So when we talk about on the last slide about a standard type of flush, if the flush is done in this application, but without any PMDK support you're doing just a standard flush. On the right-hand side, when you have direct access application, you are actually using more and more of the persistent memory support. Either you can have straight from the application, you can control the load and store operations, or the application itself is not fully PMN aware, but it can take advantage of some of the enhancements of DEX file system. Just point out that Windows does support PMDK from Windows 2016, but 2019 definitely it's a full support for PMDK. You can find PMDK, and it will actually help you port your applications if you do have some to be aware of persistent memory. So you might have heard that we have different modes of using a persistent memory device, or you used to call also NVDIMMs. You can see by the difference on the stack layers that the less overhead we have, obviously we're going to have a bigger performance. So on the left-hand side is basically your traditional I/O stack, where you have your file system, your volume manager, your disk manager, your store port, your mini port driver till you get to the block device. Could be SSD, HDD, or any type of regular block device. On the right-hand side and on the two layers, on the two stacks on the right, we're both using SEM or storage class memory, could be Optane PM. And we can have two modes. One is a storage over app direct. Basically, we're presenting that persistent memory device as a disk, regular disk. So the I/O itself from the application has not changed at all. We're just mounting a file system on a really fast device. And on the most right-hand side, what we call an app direct, where we are taking advantage of persistent memory at all, or actually we're taking advantage of the persistent memory at their full capability. We have byte addressable data straight from the device. And you see that you have way less layers on the stack. Technically, I already mentioned some of the modes. So when you're using Optane DC persistent memory, we're going to have three basic modes. One we call memory mode, app direct, and storage over app direct. The first two, actually, let's go back. Memory mode, basically, it's how it says. It's just using the Optane persistent memory as a volatile memory. So you're not going to have any persistency, and the operating system will just address that memory region as RAM. So you see basically as a RAM support. An app direct will be the persistent memory model devices where you use as a direct access. And storage over app direct, I'm presenting that persistent memory module as a regular block device. So if we go back to our previous slide, basically the middle one is a storage over app direct, and the right one will be app direct. So we're going to have a DEX file system in the app direct mode, and the storage over app direct, we will not have a DEX file system. And how can we use that with Microsoft SQL? So Microsoft SQL presents a breadth of possibilities to use that new technology along with the Xeon CPUs. So we can accelerate and maximize our investment. Our Optane technology lineup available to be used with Microsoft SQL. Obviously, it's software and hardware version dependent. So we need to make sure which SQL version are you using, which operating system are we using in order to make sure which modes are we able to use now. A little bit more details. This is our diagram for memory mode. Like I mentioned, memory mode is just extending my memory footprint on my server and has an idea of near and far memory. So my near memory is just a write-back cache, which is your regular DRAM DIMMs will be there. And the far memory will be the Optane DC persistent memory. But even though it says persistent memory, it just works like memory. So every time we reboot the system, there will be no persistency in this mode. But it is an idea to increase your memory footprint for like in-memory database. And the whole memory usage is done by the memory controller on the CPU. So that's why we are tied to a hardware version. We need the latest Xeon 2nd generation in order to use that, because we do have the memory controller ready to understand this near and far memory. Obviously, we will try to keep most of the hot data on the near memory side, which will have very little impact on the performance. But if you have so much hot data that you spill over, we will need to make sure that the application can handle that difference in memory latencies. An app direct mode is where we're going to mount a file system as a DAX, as a direct access. And basically, this is where we see lots of applications where your database files are mounted straight from the persistent memory part. And we have way faster performance just because we are not moving data from memory subsystem to this subsystem. Everything happens in place, so there's no paging, no context switching, no interrupts, no kernel code to be executed to move data from one side to another. We just doing a load and store on the memory, on the media. So it's really a different concept on how we persist data from the old disks. Is cache coherent? Obviously, we need to flush our cache from the CPU to the memory controller. So when we see this dot line is where we have a power fail protected domain. So the new hardware also will come with this behavior where we will have a power fail protect domain to the memory controller. And just one cool idea is that we can DMA or direct memory access, or we can do RDMA with PMN as well. And the third mode is this storage over abstract. Like the title says, is basically a block storage. So we mount a regular file system on top of a persistent memory device. And we have the same type of behavior as if it were a regular disk. So it still has higher performance, but like I showed the difference in performance from regular storage to storage over abstract is going to go to be less and less because we adding a lot of overhead from the iOS subsystem. On the Linux side, we need to be at least on kernel 4.2. On the Windows side, we do support out of the box. So I talked a lot about Optane persistent memory, and how about the SSD? Well, the SSD was the first Optane media or 3D cross-point media device that Intel has launched, and it is readily available and can be plugged on any type of hardware. So there is no requirements for the newest CPU or the newest hardware. Is an NVMe device. It's the fastest NVMe device we can find today, and there's lots of use case that we can think about it. Just think about, I really need a fast disk device on my current hardware, and you can think about Optane DC SSD. So let's talk about some regular or general use cases. So that's more an overview. I won't be going on any numbers because they differ a lot from case to case. So my first scenario would be, I have a hardware, but there's no persistent memory support. So in this case, use Optane SSD, or you can use Optane SSD as a fast block device. So one of the cases that I normally find very useful for Microsoft SQL or any relational database is to place your temp and DB and transaction logs on the Optane SSD. That's kind of the win situation where you don't have to move your whole database to the same device. You just split the I/O footprint to Optane, like transaction logs and TempDB will definitely speed up some of your Microsoft SQL workloads. Second case, I have hardware with persistent memory support, but my software does not support. For instance, I don't have the latest Microsoft SQL version. So how can I use that? So you could use Optane as memory mode. So you can just increase your memory footprint because it is so low in the hardware stack as the operating system we just see as regular memory, regular DRAM, and use Intel Optane DC SSD as the fast block storage. So you do have that option. A third option would be to use the persistent memory as a storage over abstract, which will show as a regular block device. You won't have any direct access, no DAC support, because your application does not support it yet, but you could use at a fast block device. So big case to test that. Now I have a hardware that supports PM, but I have reduced PM support, like the Microsoft SQL 2016 with tail of the log. So you can just mount your PM, your Optane persistent memory as abstract mode and use the tail of the log feature for that. Just remember that the tail of the log does not need that much of a capacity footprint, so you could use just a bit of your persistent memory as abstract and the reminder as a memory mode. So we also allow you to have that flexibility, so you don't need to use 100% of in one mode or the other. You could pick and choose the capacity that you want for memory and the capacity you want for storage. And you could use Optane SSDs for TempDB and transaction log because we are doing tail of the log only, but we still need a really fast block device to support that. We could use extend buffer pool with persistent memory. So if SQL vNext, which is 2019 now, we have what they call hybrid buffer pool, which is basically use persistent memory as an extension of the SQL Server buffer pool. So you add your Optane persistent memory, set it at app direct mode, and you set up your SQL to use HP or HBP in this case, hybrid buffer pool. So technically, hybrid buffer pool is just going to use memory map IO to clean pages for the PMN space. So your dirty pages will stay on DRAM, and your clean pages on the PMN side. And this is controlled by SQL itself. And the last one will be what we call Enlightened version, which we take advantage of the full persistent memory mode, where I can store all my database and transaction log files on a DEX volume, on a DEX aware volume. Today on CTP for Microsoft on Linux, we have that mode. So if you do use Microsoft for Linux vNext 2019, that's the Enlightened mode that you can start testing, where you can mount a device as DEX. So you're going to mount XFS or XT4 volume with the DEX flag, which is the direct access flag, and place your SQL databases and SQL database files on top of it. And one point is to enable the trace flag 3979. So you disable some of the force flushed that we won't need, obviously, for the PM side, for the persistent memory side. With all of that, just remember there are lots of flexibility with Optane technology. So you're not bound to use one mode or another. You're not bound to use only Optane persistent memory and not Optane SSD. You can either mix and match and use both of them. So what we'll decide is your use case, your scenario, what's the best TCO in that case, what's the best bang for your buck in this case for performance and cost. So some takeaways, modernize your legacy to Azure or on-prem. So in order to take advantage of all that enhancement that Intel is putting on the hardware, we need to also upgrade the software. So they are together. We mentioned that for this presentation, we have great flexibility in server design with Optane technology on both bare metal and virtualized. So all those techniques that I presented also could work on a hypervisor. So we could present a persistent memory device to a virtual machine, what we call VPMN, and have some of those ideas on a virtualized environment. Just make sure to remember that both log technologies can share the same server. So I can have Optane SSDs and Optane PMN and storage over AppDirect on the same server, and which one will have may have different performance characteristics. So you could have your tier 1 database on PM and a tier 2 database on Optane SSDs. So again, we need to test and see which one will behave better for you. Always remember that it is software enablement. So even though you may have your hardware supporting persistent memory, if your operating system and your application do not support, you want be able to take full advantage of it. And go back and select which use case is more important and test it. Either it's a memory extension case where you have a in-memory database where I want a very large memory footprint, or I want a persistent memory database where I want to load and store the database straight from my PM device. I could have fast storage over a PM device, which is that storage over app direct. So I mount a regular file system on a persistent memory device, and I don't have to change anything on my application because I'm just using regular read and write APIs. And fast storage over block device. So if your hardware does not support Optane PM, or you don't see much of a use case, you still can use SSDs, regular SSDs on Optane SSD devices. So basically, it should be something around those lines. I hope you have some questions for me, and that was basically what I have. I know I talk fast, but I hope we have some time for questions. Thank you.
Thank you very much, guys. That was brilliant. My head is starting to hurt a little, though. Hopefully the audience understood it slightly better than my mind could cope with. But yeah, we do have some questions. The first question I want to ask is, I think you did allude later on in the presentation that there was Linux support for this technology. If so, what file systems on Linux do you support? Sorry, guys, I don't know if anyone's speaking at the moment. You may be on mute if you're currently talking.
Oh, I'm sorry. Yeah. So yes, Linux actually is the current solution that does support the full breadth of Optane PM on so SQL 2019 actually on CTP 3. So we have what I mentioned as an Enlightened version. And as far as file systems, either ext4 or XFS. So my personal favorite would be XFS, but either one of those have support for DEX volume. Just make sure when you mount, you need to manually specify that you want to mount a DEX volume.
Excellent. I'm personally a big fan of BTRFS file system. I don't suppose that's on the sometime in the future, is it?
Not that I'm aware of.
Okay, right. So we've had one very, very busy attendee who's asked lots of questions. So we'll ask a couple and then move on to other people's. So George Carlisle wins the award for the busiest attendee. How will migration work with software with Optane? Can a SQL Server with DRAM be migrated to SQL Server with Optane? Can you talk about how this will work?
So from a SQL perspective, if you're not, you can just move files from one server to another. So you could technically detach and attach as long as it supports the. So if you have a old SQL Server, and so the migration path should be the same as we have been doing, because your target will support that. And SQL will know that you're placing a file on persistent memory. So it shouldn't have any special things to do that. We have to talk to Microsoft, but as far as I understand that will be just a seamlessly transition as long as you, so there is no in-place upgrade, but just move your database files from one place to another, the way you've been doing. Yeah.
So it almost sounds like from a DBA perspective, the experience will be almost transparent to them.
Correct.
Awesome.
My goal for this is just to present some of the options we have on the hardware, but from the DBA perspective, that shouldn't change. What will change is the performance.
Fantastic. He then goes on to ask, what are the pitfalls to watch out for with persistent memory, particularly with SQL Server in mind? Are there any?
So that will depend on the mode that you're doing. So if you're on the memory mode, which is just RAM, and so there's no persistence, it would be the amount of hot data that you have, because there is a difference on if my my cache, which is my current DRAM, is not full, so you have almost a nearline performance. But if you have too much cache miss from DRAM and going to a persistent memory mode, you may see some. So if you are purely read heavy and there is not much churn of data, so your data does not change much, that's not a big deal. On the persistent memory side, it will all depend on who is controlling flushes. So as soon as Microsoft launches that support, it means that Microsoft integrated the PMDK into the code, and it has a full flush control. So from a DBA perspective, I don't see much of the pitfalls, but as a developer, if you're controlling flush, that's where you're going to see more of the pitfalls. So again, as a user of an application, since Microsoft supports on Linux, you start testing on Linux, and hopefully down the road, the Windows SQL Server on Windows will be supported full persistent memory stack.
Fantastic. Okay, we've got a question from our resident hardware expert, Glenn Berry. Are 1.5 terabyte Intel Optane DC P4800X drives actually available yet?
They should be available. They are on the street. They are hard to find, but they are available.
Okay.
And tell Glenn that he can ping me offline on Twitter, or anybody who has further questions. That's fine.
Okay,
Yes, they are available.
Excellent. He also goes on to say that, is it true that the Intel Optane DC persistent memory runs at 2666 megahertz, so your 2933 megahertz DRAM will be slowed down to 2666 megahertz if you use PMEM?
True. Okay. It's because the buzz, we need to get the buzz on a certain level in order to, so
yeah,
that there will be a loss, some loss of bandwidth. So bandwidth will be something that we need to take care when we testing the hardware with persistent memory.
Okay, brilliant. I caught in the presentation that you said that block size is configurable. I was wondering, is this dynamically set through, or can it be dynamically set through applications, or does this have to be set up front?
Yeah, so the block size will only matter if you're doing storage over AppDirect. So if you're using a regular file system on top of a persistent memory DIMM. If you're using a DEX, so there is no point on setting up a block size, because there is no the legacy concept of a file system is not there anymore. We're going to be byte addressing memory, so we are on a 4K boundary, or 2 megabyte boundary, or 1 gigabyte boundary, depending if you're using large page or huge pages on Microsoft or Linux. So the block size is only a matter if you're doing just storage over AppDirect, which is basically regular IO subsystem.
Okay, fantastic. Can ARM processors use Optane? Any idea when Intel is going to announce pricing for Optane? Sorry, that's the second question. Yeah, so can ARM processors use Optane? Is the first question.
What process? I didn't quite.
So, well, I'm presuming the question really is do Intel have an ARM processor that is using Optane?
Oh, an ARM.
ARM?
An ARM. All right. No.
No.
No, for persistent memory.
Yeah. Okay.
Optane DC SSD is just a PCI bus, so regular
Yeah.
PCI bus. So if it is just the SSD, it should be fine as long as it can mount.
Yeah, you have to use the second generation Xeon Scalable, what we're calling as Cascade Lake for
Right.
persistent memory.
Great. And any idea when Intel is going to announce pricing for Optane PMEM?
There'll be more Eman.
It's generally available. That's what we announced yesterday. So
Okay.
trying to figure out if the pricing is already on our website or not, but you should certainly reach out to your favorite OEM.
Okay. Great.
Let me check while you're asking questions.
So we have a question here from Bjorn who asks if you are using availability groups. He says PMEM is disabled on the primary. I don't know if he's asking that question or he's asserting that. How much slower than normal memory will PMEM without PMEM mode be? So I don't know, is that a correct assumption first, that you would have to disable PMEM on a primary of an availability group? Because I don't recall you mentioning that at all.
No, I haven't tested that, but if you think about the availability group, is just a per server, and you're just transferring transaction logs. So you're just
Yeah.
so I don't think we'll. I have to look at Microsoft. I'm not sure about that, but
Yeah.
from looking at the technology, I don't think it would be that different. But
Yeah.
since if you're doing synchronous replication, then it will slow down your primary just because you're taking longer to commit transaction on the secondary node, which
Exactly.
will be regular. But they should be independent because it's a internal application, and the operating system should. But Microsoft should be the one to respond if it will be supported or not, right? So
Yeah.
I cannot say if it's going to be supported or not.
Yeah, and of course, I mean, there shouldn't be any reason why it isn't, as far as I can see. As long as your secondary as well has PMEM support, if you're running synchronous, then you'd get all the benefits of PMEM on across your replicas. Yeah, okay. Well, with any questions that we haven't quite answered, we'll obviously follow up and get them published and to the people that have asked. Okay, we've probably got a few more minutes, if you're okay, guys, to ask one or two more questions. Right, so got a couple of questions here from my friend Ned Otter. What features are unsupported with hybrid buffer pool, i.e. compression, transparent data encryption, Hekaton checkpoint files? Is there any unsupported SQL features that you're aware of?
Not that I'm aware of. So from a hardware perspective, from hybrid buffer pool, we just need a persistent memory. But I'm not aware which features are supported or not.
Right, cool. And he then goes on to say, does Optane latency increase as capacity and demand increases?
Optane SSD. So I can talk about that first. No, because the SSD on Optane is very different from regular flash. So there is no garbage collection or over provisioning on the device itself. So the latency is very, let's say, flat or consistent across reads and writes and capacity points. And for persistent memory, we should go away from that because we're just managing a byte address. So regardless how much data we have, we're addressing just a pool of data. What may change is if you're controlling how you're persistent, at which point you're persistent in your data, to the device that can slow down because of synchronization, right? So you're flushing some data and you have other data that's dependent on that. And once I'm on the flushing process, that will be locked. But it's a completely different idea. So from an SSD perspective, Optane does not have that effect of.
Excellent. Have a question again from George. He mentions that in the past SSD obviously had this thing with a limited lifespan, and I know things improved with lifespan of SSD disks, but he's asking what can we expect PMM lifespan to be, or Optane lifespan to be?
It's with our media on both SSD and the persistent memory, which is the 3D crosspoint, really has a high lifespan. So let me talk about the SSD, which is my primary product. Today, Optane SSD can have up to 60 drive writes per day. So we could rewrite the same point or 60 times per day on the 5-year period. So it's way above the regular 3D NAND TLC SSDs that we have in the market today. And the same features apply to the memory. So I'm not saying that it's 60 drive writes per day, but just pointing out that the media itself has a really high shelf life, and you should expect to have the same life or throughout your hardware lifetime as well. So I don't expect us to have any wear out problems with the media.
Okay, brilliant.
And the media itself, also with the support, we can scrub and do ECC. So if you have any pages that are not okay, the memory controller itself will move data around. So the application will not need to take care of that.
Fantastic. All right. Well, we've run out of time now. I really appreciate you both giving this session. It's been really entertaining and informative, and I really can't wait to get my hands on Optane if indeed I ever get a chance to. But I'm really looking forward to seeing it sometime. So I appreciate you guys presenting.
All right. Thank you very much. Thanks a lot.
Cool. And for the rest of you attendees, then you may want to hop on now to the next session, which is Intro to Data Storytelling with Power BI by Erin Ostrowski. Thank you, everyone.